Hi guys, welcome to ELEC120 Electromagnetism and Electromechanics Problem Sheet 1 on electrostatics. So in these videos what I'm going to do is I'm going to go through the problem sheet solutions and I'm going to explain to you why the answer is how it is. So it's like me sitting there going through the problem sheet with you. If you've got any further questions, please come and talk to me. But these are your first point of call, and obviously you can look at them at a time that's convenient to you. So these questions are taken from past exam papers, so if you can answer the problem sheets, you'll be able to answer the exam questions. So question 1, explain briefly what is meant by the concept of field lines in electrostatics and state how they are related to field strength. And then the second part is to write down an equation for Coulomb's law that describes the force between two charges Q1 and Q2. So let's start off with the first part about field lines. Well, field lines relates to this area of the lecture notes. So if you have a positive charge, you'll have field lines radiating out from it, and if you have a negative charge, you'll see the field lines radiate in. What the point of these is that if you put a test charge, which we by default use a positive unit charge, which is the charge of an electron even though it's positive, and you place it somewhere in the field, somewhere in the vicinity of a charge, you see what happens to it. So obviously if we place a positive charge here, it will move away from the positive charge that already exists, and if it's a positive test charge here, it's going to move towards the negative charge. That's the law of electrostatics. So let's go about solving this. So the actual answer is for field lines. Any field is a variation of some quantity with distance, so you can apply this to electric fields or gravitational fields is a good example. If you think about it, if you're further away from an object, it exerts less gravity on you. The gravitational field is less. It's the same kind of thing with an electric field. So an electric field, which we give the figure E, is a quantity of the force experienced by a unit charge placed anywhere in the space around a charge. That's what I've just explained, but in a much more concise form. So field lines represent the direction of a force felt by a unit positive charge, and we use an arrow to show the direction. So that's the stuff about it going away from a positive charge and towards a negative charge. The bigger the positive charge, the more field lines there will be. So for a larger Q, which means it's a larger charge, there'll be more field lines. This is given in the equation for electric field strength, and that equation is E is equal to Q, which is the charge, over 4 pi times epsilon naught, which is the permittivity of free space, times r squared, where r is the distance you are from that charge Q. We're going to talk a lot more about epsilon naught and permittivity later on in the lecture series, so for now all you need to know is epsilon naught is a constant because we're operating in free space, so it's the permittivity of free space, and this is a reference number. It's 8.854 times 10 to the minus 12, and you'll know it off by heart by the end of this module, but you will be given that in an exam. You won't be required to memorize it. Now we go on to Coulomb's law. So Coulomb's law is about what is the force between two charges which are placed near to each other. So F is the force in newtons, and that's equal to Q1 times Q2, so the charge in coulombs of charge 1 times the force in times the charge in coulombs for charge 2, all over 4 times pi times epsilon naught times r squared. So that means that the force experienced is proportional to the magnitude of the charges and the distance they are from each other, essentially, because all the rest of these things are constant.